All right, Mr. K is chugging along. This is 2023 AB5. And what did I say? This one was FTC. Oh, I think it's part C. Part A and part B is easy peasy lemon squeezy, honestly. You're trying to find H prime of 7 for part A. F and G are twice differentiable, which means that H is also differentiable. Do you want to say that? Just to be safe, probably write that down. So because F and G are twice differentiable, H of X is differentiable. And then this is just using chain rule. So then using chain rule, we get F prime of G of X times G prime of X. Plug in 7. Now, I had a couple of people not being happy about how you can't just leave it like this. You have to plug in the numerical values whenever you get to this part. So do not stop here. G of 7 is 0. And then F prime of 0 is 3 over 2. And then G prime of 7 is 8. And then at this point, if you want to stop here, then you could stop here. Okay. Let K be the differentiable function such that K prime of X is equal to that lovely thing right there. So they were nice to give you K prime of X. Because what's going to happen here is it's asking you, is the graph of K concave up or concave down at X is equal to 4? Give a reason for your answer. Well, since we're talking about concavity, we have to take the second derivative. I don't know why that took me so long. The second derivative is going to require a little bit of product rule and then chain rule whenever we do f of x squared right here. So we have first times the derivative of the second plus second times the derivative of the first, which becomes 2f of x, f prime of x. And then we just gotta plug in everything in terms of 4. Ooh, this is nasty. Anyways, f of 4 is 4, so then 4 squared gives us 16. G prime of 4 is 2. G of 4 is negative 3. 2 times f of 4 is going to give me 8 plus, oh, not plus, times f prime of 4 is 3, which gives you that right there. So now you have like 32 minus 72, which equals negative 40, which is less than 0. Because k double prime of 4 is negative, we know that k is going to be concave down at x is equal to 4. So we could say that k is concave down at x is equal to 4 because k double prime of 4 is less than 0. Call it a day. All right, part C, we have m be the function defined by that lovely thing. Find m of 2, show the work that leads to your answer. Okay, so this one here, we aren't even taking a derivative. We're just finding out m of 2. So m of 2 is just 5 times 2 to the third plus the integral from 0 to 2 of f prime of t dt. I have a problem again. Whenever we take the integral of 0 to 2 of f prime t dt, I'm going to have to use FTC, which means that this right here, let's see, 840, becomes f of 2 minus f of 0. F of 2 is 7. F of 0 is 10. So we have 40 plus 7 minus 10. You want to keep it like that? That's fine. If you want to simplify this and get 37, that's also fine. Just make sure that you actually simplify this correctly, though. Okay, and then part D says, is the function in part C increasing, decreasing, or neither at x is equal to 2? Justify your answer. So now we want to see what the first derivative is doing, and then seeing if the first derivative is positive, we're increasing. If the first derivative is negative, we are decreasing. If that derivative is 0, nothing's happening. So that gives us 15x squared plus f prime of x. We are looking at 2. F prime of 2. 60 minus 8 is equal to 52. Since f prime of 2 is positive, so because f prime of x is greater than 0 at x is equal to 2, the function m is increasing. Notice how I was very specific in terms of my wording here because I said the function m. You'll see that we have f's and we have g's, and now we have m's. We had a k up here at one point, and then we had an h here at one point. So that's why we are not very big fans of it. So please do not use it in terms of justifying your answers. Please and thank you. All right, our next FRQ, our next video, we will use the calculator.